Hello everyone. This is a little video over parallel lines and transversals. So this covers 3.03 and 3.04. We're going to review the vertical angles that was talked about in the previous lesson, but then we're also going to talk about the special angle pair theorems. So let's go ahead and start with the vertical angles. Remember that vertical angles, those are two angles that are formed by intersecting lines. So we have the two intersecting lines here. And they intersect at one location right here, one intersection, okay? So it's very, very important to remember that vertical angles are at one specific intersection, okay? The vertical angles are at the same intersection. The angles that are opposite of each other, those are the vertical angles, okay? So they're opposite sides of the point of intersection. So that would be like this red one and this red one. One thing to always remember is that vertical angles are always congruent. That's what this sign or this symbol means right here, congruent, which just means equal. So if this angle were to be, let's say 60 degrees, okay, then that means the vertical angle that matches up to it would also be 60 degrees. Now remember, we talked about these before, that whenever two angles form a straight line, like the blue and the red right here, those are called a linear pair. So they add up to 180. So we can easily find that blue angle by going 180 minus 60, which ends up being 120 degrees. And remember, opposite angles, or those vertical angles, are always congruent. So this one would be 120 degrees. Let's look at an example. So it says, name two pairs of vertical angles. So we are just looking at the opposite angles. So here is our point of intersection. So you've got this angle and this one. So we could say angle MQR and angle LQX. So LQX right here, and then MQR. Now another example would be these opposite, or these vertical angles here. So we'd have XQM, and the other side, which is LQR. Okay, so if angle MQR is 118 degrees, so let's go ahead and label that one, MQR, which is this guy right here, MQR. They're saying that that is 118 degrees, and they want to find what is the value of XQL. So XQL is this one that's just, and so we named those as a vertical pair right there. So if MQR is 118, then XQL will be 118. The correct answer is B. Okay, so before we get started with the special angle pair theorems, we need to talk about a few vocabulary words, okay? These are really simple. It's just interior and exterior. And you guys know what interior and exterior means. Interior just means inside, and exterior would be outside, okay? Now, what are we talking about? Inside and outside of what? Well, we're talking about two lines here. And let me go ahead and highlight the two lines we're talking about here and here. Notice that between those two yellow lines, we call that our interior, okay? So this is the interior. All of this stuff that's between them. Everything that's on the outside of those lines is called the exterior, okay? So inside and outside, or interior and exterior. Another word we're talking about is parallels and transversals. So the two lines here, we know that the two blue lines, we know that they're parallel because they have this arrow, okay? We've talked about that before, that these arrows that are on the lines, that tells us that those two lines are parallel, okay? So the transversal, which is that red or pinkish line, okay? This line is called a transversal because it is intersecting our parallel lines at two intersections. Notice we have two intersections that are formed, okay? So we have interior, which is inside. We have exterior, which is outside. And we have this other new word, which is a transversal. The transversal is just the line that cuts the two other lines, okay? Now, those two other lines could be parallel, and sometimes they're not parallel, okay? Okay. So let's get started with our first special angle pair. These are called corresponding angles. Corresponding. So corresponding means that they're at the same location, okay? Same location, but different intersections. So what in the world does that mean? Let's first identify where our intersections are, okay? So we have intersection here and intersection there, okay? I'm going to go ahead and I'm going to highlight our transversal line. That is this guy. This is our transversal, okay? So these corresponding angles, same location, but different intersections. So let me show you this picture here. So let's pretend we're driving down the road. Driving down the road, here is our transversal line, right here. And I know that's hard to tell with that black, but right here, that's our transversal, okay? This car driving down, okay, every time you come to an intersection, you know that if there's going to be a stop sign there, it's always going to be on the right-hand side right there, right? The stop sign will always be there. That's because, for uniformity, we have to what if every time you went to an intersection, you had to search for the stop sign? Can you imagine the traffic that every time you'd go to an intersection, you're like, okay, where's the stop sign? Oh, is it over there? Oh, wait, I see it over there. It's on the other side. I mean, that would be chaotic, right? And then there'd be people that wouldn't even look. So thank goodness they put the stop sign in the same place at every intersection. Those are called corresponding, okay? Same place, different intersection. So notice that the stop sign is before you get to the intersection and on the right. So if you continue and you drive your car and you look, it's before the intersection on the right, okay? Another example would be like the gas station here. That is after the intersection and on the left. And the hospital is after the intersection and on the left, okay? So when they're at the exact same location, but different intersections. So some examples of that would be like angle A, okay? So notice it is at the top left-hand side of our top intersection. When we come to the bottom intersection, down there, okay, we want the top left hand. So it would be angle E. So angle A and angle E are at the same location, but different intersections. Let's look at another one. Like if we had angle C, that's in the bottom left. So G would be bottom left. Okay. Another example would be like B and F, or the last one here, D and H. Now, something really special about corresponding angles, okay? Now notice sometimes, like I said earlier, sometimes these lines will be parallel and sometimes they won't, okay? So this right here, those are parallel. They have them labeled. If they are parallel, okay, if our lines are parallel, so the lines that are being cut, if they're parallel, then our corresponding angles are congruent. Okay, I'm going to highlight that part right there. Okay, so if two parallel lines are cut by a transversal, then corresponding angles are congruent. So if those lines are parallel and they're cut by that transversal, then we know that the corresponding angles are congruent. Okay, let's look at the next one. The next one is called alternate interior. Now let's think about what these words mean here, okay? Alternate, if you alternate, it goes back and forth, back and forth. So this means opposite. We're going to say it's opposite. Okay? And interior means inside. Now remember, we're talking about inside the lines being cut. So that's going to be this part right here. Inside there. So when it says when we're talking about the alternate, that means opposite sides of the transversal. So the true definition says for the alternate interior would be angles that are on opposite sides of the transversal and inside the parallel lines. So examples of that would be, notice angle C, okay? C is, we're only looking at C, D, E, and F. C is on the left side. We have to come to the other intersection, and it'd be F. Notice these are on opposite intersections, okay? They're on different intersections. It's intersection 1, intersection 2. Another example would be angle D and angle F. Now, when these parallel lines, or when these lines are being cut, if they're parallel, then the alternate interior angles are congruent, okay? Now, I know that this, you're thinking, whoa, this is already a lot of information. You know I'm going to provide you with notes. I've got a cheat sheet. You're going to be okay, okay? I need you to know what the word alternate means, interior, exterior. I need you to know what these vocabulary words are so that way you can think through the process of identifying these special angle pairs, okay? The next one is alternate. Okay, again, alternate means opposite, right? Opposite. But this time we want exterior. Okay, so here is our transversal line. We want the exterior, so that means out here and out here. Now, our angle pairs, we have to have one of them at each intersection. So here's intersection 1, intersection 2. Okay, so we want opposite sides of the transversal and outside the parallel lines. So like A and H. Notice they're on opposite, they're on different sides or alternate sides of our transversal line, and they're on the outside of the lines being cut. Okay? Another example would be angle B and angle G. Okay. So let's look at if two parallel lines are cut by transversal. Okay, so if the lines are parallel, then the alternate exterior angles are congruent. So far, the corresponding angles have been congruent, the alternate interior have been congruent, and the alternate exterior have been congruent. Okay? Got two more. So these are called same side. Okay, that's obvious. That we know what same side means. It just means same side. Same side of our transversal. Let's highlight our transversal. That's this guy right here. Okay, we're doing interior, so that means inside. Okay, so I'm going to go ahead and highlight my inside. So we have C and E. They're on the same side and on the inside. Okay, another example would be D and F. Notice, again, each one of these angle pairs is at one, each one of the angles is at the intersections, okay? So you have one angle at one intersection and you have another angle at the other intersection. Now, if these lines that are being cut, if these lines are parallel, then same side interior angles are supplementary. Same side, supplementary. Okay? Supplementary. What does that mean? Same side, supplementary. Notice they start with an S. Now, everything else has been congruent, right? Supplementary means they add up to 180 degrees. Okay? So if angle D is 120, angle F would be 60. Together, they have to be 180 degrees. Okay? So angle D plus angle F would equal 180 degrees. Okay, so same side interior will be supplementary. And this is only when those lines being cut are parallel. Okay, let's look at this last one. Okay, stick with me. We're almost done. So here's our transversal. Okay, this time we have same side exterior. Exterior means outside, right? Exterior means outside. So we want same side exterior. So that would be like angle A and angle G. They're on the same side of our transversal, but outside of the lines being cut. And then you would have angle B and angle H. Again, if the lines are parallel, okay? If the lines are parallel and they're being cut by the transversal, then the same side exterior are supplementary. Same side exterior are supplementary. And remember that supplementary means they add up to 180 degrees. So it'd say that'd be like angle B plus angle H would add up to 180 degrees. Okay. Here is a great visual, okay? We have talked about vertical angles. Now, vertical angles are the only ones that are located at the same intersection, okay? And they're the yellow ones right here. All the other angle pairs are at separate intersections, okay? So here's a great example of, or a picture that shows you that it's color-coded of the different types, and it also lists for you who's congruent and who's 180. Notice that vertical, corresponding, alternate interior, alternate exterior, all of those are congruent. The only two that are 180 or supplementary are the ones that are called same side. So same side or supplementary. Okay? Good thing you're watching this recording and you're not in person, because if you were sitting on that front row, same side, I'd be spitting all over that front row, right? Same side supplementary. Okay, let's label some of these, okay? Let's practice them. So vertical, those have to be at the same intersection and they're opposite of each other. So that would be like angle 1 and, so angle 1 and angle 3. Or angle 2 and angle 4, okay? They have to be at the same location, or the same intersection, I'm sorry. Okay, the next one is corresponding, okay? Corresponding. Corresponding means that they're going to be at different intersections. Here's my two intersections, okay? They're at the same location, but different intersections. So we could say like angle 1. And we go down to the other intersection, the bottom intersection, and it's at the same location. So like angle 5. Or angle 6 and angle 2. Okay? Okay, the next one is the alternate interior. Now I'm going to draw in. Here's my transversal. Okay? My interior is on the inside, and my exterior is outside of the lines being cut. So we want alternate interior. So we only care about the inside. So alternate would be like angle 4. Okay, so angle 4 is on that left-hand side. Okay, remember we only care about these because they're on the inside. So angle 4, and we come down to the other intersection, and it'd be angle 6. So angle 4 and angle 6. The other pair would be angle 3 and angle 5. Okay. The next would be alternate exterior. So we only care about this out here and out here. Okay. So we could say angle 1, which is this guy right here, and we want alternate. So we want it to, when we go down, when we travel down to this other intersection down here, we want it to be on the outside, and we want it to be on the other side of the transversal line. So that would be angle 7. So angle 1 and angle 7. Okay. The other pair would be like angle 2 and angle 6, right? Or I mean, I'm sorry, not 6, 8. So 2 and 8, okay? Last one is, or no, I'm sorry, we have same side interior. Okay, so again, we only care about on the interior, but we want them to be on the same side of our transversal. So that would be angle 4 and angle 5. Or the other pair would be angle 3 and angle 6. Okay, the last one is same side exterior. So we only care about out here and out here. So this time, same side of that transversal line. So it'd be like angle 1 and angle 8. So angle 1 and angle 8. Okay, so it says in this figure, line AB and CD are parallel. Remember, that's what this line, that's what that notation is right there. It means parallel, okay? It says the measure of angle 6 is 75 degrees. So angle 6 is 75 degrees, okay? So find the measures of all the other angles. Now, we can go ahead and do the angles that are at the same intersection as angle 6. Remember that vertical angles, those are the ones that are opposite of each other, okay? Those are always congruent. So like angle 6 and angle 8 would both be 75 degrees. I'm going to go ahead and put that in there, 75 degrees for angle 8. Remember also we talked about at the beginning how when two angles form a straight line, they add up to 180 degrees. So to find angle 5, we would say 180 minus 75. So 180 minus 75 would get us 105. So that means angle 5 is 105. And remember, angle 5 and angle 7 would be vertical, so therefore they are congruent. So angle 7 is 105. Okay, now I personally think that, hey, we corresponding, same location, different intersection. So here's our first intersection right down here. And we've found all of the angles at that bottom intersection. So if we can just match up who's corresponding, then we know that they're going to be congruent because corresponding angles are congruent. Okay, so like angle 6 is in the top right. So up here we'd have angle 2. So angle 2 would be 75 degrees. Another one would be angle 3 and angle 7. So if angle 7 is 105, then 3 would be 105. So now we're ready to just fill in. Angle 1 would be 105 because they're vertical angles, and then angle 4 would be 75 because they're vertical angles. Okay, one thing that I want to make important note here, okay? They must be on the same line to conclude that anything's congruent, okay? So like we wouldn't be able to say, C and D are parallel, so therefore angle 11 and angle 3, those are corresponding, so they're congruent. They're not corresponding because they have, angle 11 is on this transversal line, but angle 3 is on a different transversal line. Guys, they have to be on the same transversal line in order to make any of these special angle pair conclusions, okay? Okay, I'm going to leave you with this right here so you can grab a screenshot of it. It's a great visual for you to keep. But of course, if you have any questions, please reach out to your teacher. And if I went a little fast over something, remember you can always rewind and go back by. Thanks a lot. Bye-bye.